Okay, this is another question from that sheet, and in this town we're going to model this coyote and the roadrunner bird using this using a projectile, treating them this catapult effect as a projectile. So the first part is very straightforward, really. It's just the fact that we're given an initial velocity in this notation, which I think we talked about last time. We said that if we've got I'll move this up slightly. Yeah, if we've got a projectile and I choose to have the I and J directions to be like this, then our initial velocity is modelled as a vector, which is 15I. This is 15I plus 8J, and it's in meters per second. This is the velocity of this projectile. And what you've got to do in this first part of the question is this is the horizontal, and it says you've got to find the initial speed of the coyote. Right. Well, you should know that the so when we've got in vector notation, if you've got a vector v or u given by 15I plus 8j, the magnitude of the vector, which is the speed, and you notice that the magnitude of a vector, the magnitude of 15I plus 8j is given by the square root of 15 squared plus 8 squared. Okay, so if you work that out, 15 squared plus 8 squared, that gives you the speed. So if I do it on the calculator, plus 8 squared is 289, and it's the square root of 289. I don't know where. And that is the answer. 17 meters per second. Okay, so that's the first part, and the second part is if you've got a vector. If you've got a vector like this, we know 15I plus 8j, we know effectively this has component that's 15 meters per second horizontally and 8 meters per second vertically. So the angle, the exact values of sine alpha and cos alpha, where alpha is the angle above the ground. Okay, well, we've just found the magnitude of this vector, 17, isn't it? So this is 17, the magnitude, the length of this vector is 17. So we can immediately write down that sine alpha must be the opposite over hypotenuse of 8 over 17, and the cosine alpha must be 15 over 17. Okay, so that's our part A for this question. Right, so the next part is we've got to find the initial speed of the coyote in the horizontal direction. Well, these are just going to be u. Remember that these are going to be u cos alpha is the horizontal component. This is u, and u sine alpha is going to be the vertical component. We know that from part 1, u is the speed or the magnitude of the vector, and we said that u equals 17 meters per second. So therefore, by the way, this is part B, this is 8b. So therefore, the horizontal component in the horizontal direction is so B part 1 is going to be u cos alpha, which is going to be 17 times. Do you remember back in part 1 we said that cos alpha is 15 over 17, so it's 15, as we would expect, as you would expect, so it's 15 meters per second. B part 2, well, it's u sine alpha, which is 17 times 8 over 17, which is just 8 meters per second. Okay, and the equation for the trajectory of the coyote, leaving the coefficients in your equation as exact values and in terms of g where appropriate. Right, well, that's where you I'm not quite sure this one. Yeah, so that looks to me like it's a question of going back to our the equation that we had in the last question, which I'm pretty sure you don't have to memorise this equation, but do you remember the equation that we had, that we just derived in the last question? You derived an equation that y equals x tan alpha minus g x squared over 2u squared cos squared alpha. Do you remember? We had that equation. So if you want to so the equation for the trajectory, as we know what sine alpha is and cos alpha is, we know what tan alpha is, equals sine alpha over cos alpha. And if you look back to the values that we've got for sine and cos, so it's 8 over 17 divided by 15 over 17, which is 8 over 15. So you know what tan alpha is, so we can put in 8, so this is 8x over 15, let's substitute for tan alpha, and then leaving g as it is. Oh, we know what u is. U is 17, so it's going to be minus g x squared over 2 times 17 squared times, now cos alpha we said was 15 over 17, and it's 15 over 17 squared, isn't it? 15 over 17 squared. So the 17 squared here is going to cancel with that 17 squared on the bottom. We're just going to be left with a 15 squared. So in total I'm going to be left with 8x over 15. Y is going to be 8x over 15 minus g x squared over 2 times 15 squared. Okay, so 2 times 225, isn't it? So it's 450, I think. Check that out. I think you'll find that turns out to be 450. And there's your the equation for the exact trajectory. Right, so that's yeah, and part C. I need to fold this over to get part C. And part C for this was given that G equals 9.8 meters per second squared, find the range of the flight of the Coyote. And there is a cactus plant at a height 4 meters located exactly halfway along the trajectory of the Coyote. Determine whether the Coyote's latest pursuit of the Roadrunner will come to a particular end. Okay, anyway, it's one of these sort of... so what they're really trying to do with part C is to get you to use this equation that we've derived and to put in different values to find a piece of information from it. It's really just there to illustrate what the purpose of this, yeah, why this equation is quite useful. So let's keep this equation in mind for part C. So part C, so this is 8C part 1. First of all, we want the range. Now don't forget x and y. Remember what x and y are when we derived this equation. We said that x and y, or when this equation we first developed this equation, we said that this is going to be the x-axis and this is going to be the y-axis, and the range is the maximum distance. This is the range, which I think I mentioned last time. This is the range. It's the distance. It's the maximum horizontal distance that the projectile takes. So if you think about it from a purely mathematical point of view, if I said to you, what is the value of x? What is the value of x when y is 0? Well, there's going to be two values. When y is 0, x could be 0, or x could be equal to this value, which is the range. So I'm going to go back to this equation, and so I'm going to substitute y equal to 0. Into equation for the projectile. And when you set y equal to 0 into this equation, we get 8x over 15 is equal to gx squared over 450, isn't it? Okay, and and I'm going to cancel x on the... Well, actually, no. It said don't let's do it like that. I'm going to set y equal to 0. I'm going to substitute g equal to 9.81 and leave that. So I'm going to get 8x over 15 minus 9.81 x squared over 450 equals 0. Okay. Now I'm going to take out x as a common factor, and I'm going to get x into 8 over 15 minus 9.81 x over 450 equals 0. Now the reason I've done that is that I'm going to get two solutions now. I'm going to get the x equals 0, because if x was 0, then 0 times anything on the left hand side is going to produce 0. So x equals 0, which is this solution, but it's not equal to the range. So that's the one that's not going to be equal to the range. And I'm going to get a second solution when this thing inside the parentheses is going to be equal to 0, and that's going to be when, and then, or we're going to have 8 over 15 minus 9.81 x over 450 equals 0. And when you take this over the equal sign and cancel the 15s, that's going to go 30 times. So we're going to end up with x is going to be 8 times 30 over 9.81. And when you work this out, anyway, you're going to get 8 over 30 times 9.81, and when I substitute into my calculator those values, 8 times 30 divided by 9.81, I end up with 24.5 to 3 significant figures. Okay, and that is the range. So the range equals 24.5 meters. Okay, that's 8 part 1, and then it says there is a cactus plant a height 4 meters exactly halfway along the trajectory. Does that land on what that's saying is that it's a cactus plant 4 meters high, located exactly halfway along the trajectory of the coyote. Determine whether the coyote lands on the cactus. Well, if we think about it, halfway along the trajectory is exactly in the middle of the trajectory, isn't it? Halfway along. And what we want to know is what's the value of y when x is equal to half the range, because right in the middle of the trajectory is going to be half the range. And we've just worked out what the range is. It's 24.5. So what we're going to do then is say, so going back to our equation, y equals 8x over 15 minus gx squared over 450. We're going to say, we're going to substitute x equal to half the range which is going to be half of 24.5, which is 12.25, isn't it? 12.25 meters. So that's half the range. If when we substitute this in we get the value of y equal to 4, then we know that it does land on the cactus. So we get y is going to be 8 times 12.25 over 15 minus 9.81 times 12.25 squared over 450. Now, I don't know what that comes. I'm going to quickly do all this in the calculator, and we get and 9.81 times and it comes out to be, I'll call it my calculations, 3.26 to three significant figures. So 3.26 metres. So the answer, no, it doesn't. It doesn't. That's below the. Yeah, that's the point. The cactus plant grows to a height of 4 metres, doesn't it? So he's going to be, so the trajectory is going to be below the height. So the cactus, the top of the cactus is going to be 4.5 metres. It's going to be above the maximum range of that. So it's going to be, yes, he does collide with it. So, yes, it does. Okay. So that's the end of that one.